Continuation of chapter 7, DC to DC converter. In the last session I discussed about what exactly current commutated chopper. In this session we'll continue with I want to discuss load commutated chopper, and I will give some introduction to some basics regarding to Jones chopper and Morgan chopper. Okay, no need of in detail discussion of Jones and Morgan chopper. The circuit, then what is the difference, what is the concept we are applying, that only I want to explain. Okay, concentrate on load commutated chopper. Yes, write down load commutated chopper. First you draw the circuit. What is the load commutated chopper? The supply voltage is Vs. Vs is the supply voltage. Then it consists of 4 thyristors. Here T1, T2 acts as one pair. This is 4 thyristors. And T3, T4 is another pair. Yes. Then we are supplying the power to the load. Let I0 is constant. We are supplying the constant current to the load. Okay. The supply voltage is Vs. Let this is the freewheeling diode. So freewheeling diode. And this is the load. Let the load voltage is V0. Okay. Let this T1, T2 is one pair, and T3, T4 is another pair. Let initially the voltage across the capacitor is Vs with upper plate negative, lower plate positive. With that assumption, we will start the operation. Already the capacitor is having some Vs voltage. Okay, with that assumption only we can start the operation. Now see the operation of the circuit. Yes. If T1, T2 is on, with this polarity, let T1, T2 is on. With this polarity, this negative and this is positive. Let this negative is connected here, positive is connected here, means if T1, T2 is on, T1, T2 is on. If T1, T2 is on means, let this is the capacitor. If T1, T2 is on means what is the equivalent? The capacitor will discharge us like this. This is T1, this minus plus Vs, and this is T2, supplying the power to the load. This is load. Okay. Then plus minus Vs. Let this is plus minus V0. Then this is T1, T2 is on. This is T1, this is T2. Then what is the voltage V0 equal to 2 Vs. But if T1, T2 is on means capacitor is discharging and discharging from positive plate to negative plate. Then after some time, then this becomes positive and this becomes negative. Once this becomes and this is positive and this is negative, then automatically T1, T2 will be turn off. Understood? Now, if T1, T2 is turn off, then only we can trigger the T3, T4. After turn off of one pair of thyristors only, we can trigger another pair of thyristors. Before it is not possible. This is one drawback. Okay. Now we can T3, T4 is on. If T3, T4 is on, tell me. If T3, T4 is on, if T3, T4 is on, what the equivalent you tell me? This is Vs. T3, T4 is on. This is T3 thyristor. Yes. But point to remember, before turn on of T3, T4, before turn on of T3, T4, before turn on of T3, T4, T3, T4, to supply constant current to the load, to supply constant current to the load, constant current to the load, then which is on? Freewheeling diode is on. This is important. Now here, before turn on of T3, T4, which device will on? Freewheeling diode will supply the current to the load. If freewheeling diode is conducting, what is V0? 0. Now we can turn on T3, T4. If T3, T4 is on, what is the polarity at the time of turn on of T3, T4? This is negative, this is positive, Vs. And this is the load. T3, this is T4. T3, T4. And this is the load. Okay. If T3, T4 is conducting, then it supplies the current to the load. It supplies the current to the load. If T3, T4 is conducting, minus plus Vs, minus plus Vs. Then what is V0? Again V0 equal to 2 Vs. Then during the conduction of T3, T4, after some time, then it becomes positive, then it becomes negative. Again we can trigger the T1, T2. It comes to the first state now, then it becomes negative, it becomes positive, then we can trigger T1, T2. Before triggering of T1, T2, in order to supply the current to the load, then which will conduct? Freewheeling diode will conduct. Like this, the operation will be continued. That means first I will trigger T1, T2, then automatically T1, T2 will be turned off, then we can use, then before triggering of T3, T4, freewheeling diode will conduct, then T3, T4 will supply the current to the load, then again we can trigger the T1, T2. Like this, automatically thyristors will be commutated because of capacitor. Okay, then this chopper is nothing but a load commutated chopper. Based on this, if you draw the waveforms, I am drawing the output voltage waveform. Based on this, here I am drawing V0 waveform. That you will see how we can expect the waveforms. Let this is triggering pulses for T1, T2. This is IZ1, IZ2. And this is triggering pulses for T3, T4. And this is IZ3, IZ4. Let this is voltage across the capacitor, VC waveform. Let this is V0 waveform. Okay. Now Here T1, T2 is triggered. If the triggering pulses is applied to T1, T2, let capacitor is changing its polarity. That initially it is plus Vs, then it is changing plus Vs to minus Vs. Capacitor is changing its polarity. Once capacitor is changing from plus Vs to, this is Vc, plus Vs to minus Vs, after changing completely to minus Vs, then T1, T2 will be turn off. When T1, T2 will be turn off, freewheeling diode will be on. This I am drawing V0 waveform. This we can get V0 waveform. Suddenly if T1, T2 is triggered, what is V0 equal to 2 Vs. This I am drawing V0 waveform. Let's note down this. This is T and this also T, taken time. Then this is V0 waveform I am drawing. Once it is reaches to minus Vs, T1, T2 will be turn off. This is 2 Vs. Now here which device is conducting? Freewheeling. If freewheeling diode is conducting, what is the output? 0. If freewheeling diode load is short circuit, now output is 0. Here freewheeling diode is conducting. Here I trigger again T3, T4 is triggered. The triggering pulse is applied to T3, T4. Again the capacitor is changing from minus Vs to plus Vs. Minus Vs to plus Vs. Minus Vs to plus Vs. Okay. Now during this T3, T4 is conducting now. Then what is the output voltage? Again it is 2 Vs. Okay. This is 2 Vs. This is one time period. One pair of thyristor and freewheeling diode is conducting, then it is taken as a one pair. Like this, the cycle will be repeated. Okay. Again, if you trigger the T1, T2, here which device is conducting? Freewheeling diode. Again, we can trigger T1, T2. Again, it's changing from plus Vs to minus Vs. Like this, we can. These are the waveforms. Okay. Now, tell me. Here I want to define what the circuit turn-off time. Circuit turn-off time is nothing but it is the time taken reverse voltage applied across the device, either T1, T2 or T3, T4. Here this is positive voltage with respect to T1, T2 and this is the negative voltage with respect to T3, T4. Negative voltage with respect to T3, T4. Okay. Then this is the negative voltage with respect to T1. For T1, T2, this is negative voltage. That's why this time is taken as a circuit turn-off time. And this is also taken as a circuit turn-off time. With respect to one device, I am telling. With respect to one device. That's why, can you define like this? IC equal to C into dV by dt. But the current through the capacitor is nothing but a current through the capacitor is nothing but a current through the load current. This IC equal to I0 C into 0 to minus Vs. This is the circuit turn-off time with respect to T1, sorry, T3, T4. This is the circuit turn-off time with respect to T1, T2. Circuit turn-off time we calculate with respect to one device only. That's why we can calculate 0 to minus Vs means change in voltage is Vs by this time is called circuit turn-off time. Then what is TC equal to CVS by I0. This is the circuit turn-off time of load commutated choker. Now I want to find what is the average output voltage. What is the average output voltage? The average output voltage is equal to, tell me. This is in one time period. 1 by 2 into 2 Vs into, this is total time period, means this is which time? On time, T on. That is 2 Vs into T on by T. Then what is the average output voltage? 2 cancel. Vs into T on by T. T on by T is nothing but duty cycle, or it is also called Vs into T on into F. Okay, this is what is V naught equal to Vs into T on into F. Okay, that what is the minimum on time? Minimum on time is T on. Minimum on time is T on. After this only, next T3, T4 will be on. That's why the minimum on time in one period, the minimum on time is T on. Then minimum on time means maximum frequency. What we can get? 1 by T minima. What is 1 by T on? Then what is the maximum frequency of operation of this circuit? T on equal to 1 by, that is Vs into T on into F, where F is the switching frequency. 1 by T on. 1 by T on gives the maximum frequency of operation. Next, one more point to remember. Here we are getting T on equal to, yes, V naught equal to Vs into T on by F, that equal to dVs. Then maximum frequency of operation equal to minimum on time. Minimum on time is how much? T on. That you take the 1 by T on. Okay. And this is the circuit turn off time. This is the average output voltage, and this is the maximum frequency of operation. These points you remember with respect to load commutated chopper. Then what is the advantage of load commutated chopper? What is the merits? What are the merits of load commutated chopper? Point to remember. It is used for to commutate any value of load current. That means for any value of load current, these choppers are preferable. These are used for any load currents. For any load currents. For any value of load currents. For any value of load currents. These are preferable. For any value of load currents, these choppers are preferable. This chopper is preferable. That is, this chopper is preferable. This chopper is used. This one more advantage of load commutated chopper is, it does not consist of commutating inductor, hence it is less cost, less noisy and less bulky. That is, because of absence of commutating inductor, because of absence of commutating inductor, absence of commutating inductor, yes, commutating, because of absence of commutating inductor, it is less noisy, less bulky and less cost. If inductor is not present, all these are the advantages. And used for high frequency applications, used for high frequency and minimum filtering requirements, and it requires minimum filtering requirements. Minimum filtering requirements. All these are the advantages. But what are the demerits of this chopper? Demerits. One of the demerit is, if it is used for high power applications, it offers less efficiency because of high switching losses. Because at a time, Each time how many thyristors are conducting? 2 thyristors are conducting. It offers high switching losses. At a high power applications, for high power applications, efficiency is less. Efficiency is less because of more switching losses. This is one drawback. That point to remember. The another drawback is, yes, by turn off of one pair of thyristor only, we can trigger another pair of thyristor. That means by completely turn off of one pair of thyristor, then you can trigger another pair of thyristor. But before turn off of T1, T2, we cannot trigger T3, T4. That means one pair of thyristor is turn off, one pair is turn on, one pair is turn off, then only another pair is turn on. Okay. For high power applications, efficiency less because of more switching losses. One pair is turn off, then only another pair is turn on. Okay. All these are the demerits, and these are the advantages. That is the merits. Hold on, quick. But one more drawback is also there. Yes. What is the peak inverse voltage across freewheeling diode? If T1, T2 is conducting, freewheeling diode is under reverse bias condition. What is V0? 2 Vs. That's why peak inverse voltage across freewheeling diode is 2 Vs. Peak inverse voltage across freewheeling diode is 2 Vs. That is peak instantaneous voltage across the load, similar to that of voltage commutated choker. This also another drawback. Clear? Concentrate. Okay, this about in detail about what exactly load commutated choker. You concentrate on what is the circuit turn off time, what is the maximum frequency of operation, what is the average output voltage, merits and demerits. One of the special feature of this load commutated choker is it consists of only capacitor. It does not consist of inductor. It requires only commutating capacitor only. It does not require commutating inductor. But in the case of voltage commutated choker, L and C elements are used. But in current commutated choker also L and C element. But here only capacitor we are using. Because of absence of capacitor, size will be reduced. And noise is also reduced. That is the main feature of this load commutated choker. Clear? Okay. Then you go for 1 or 2 points with respect to Morgan choker and Jones choker. You can write on Jones choker. It's clear? Okay. Yes. Jones choker circuit. Yes. But the Jones choker means it is similar to that of voltage commutated choker, but only difference between Jones choker and voltage commutated choker is in the voltage commutated choker, mainly in Jones choker, instead of inductor we are using the center tap transformer for effectively turn off of thyristor. Okay, in the case of voltage commutated choker we are using inductor, but here we are using center tap transformer, but remaining concept is same. Okay, that's why in Jones choker which commutation we can use means voltage commutation we can use. The concept is same, but instead of inductor we are using center tap transformer for effectively turn off of thyristor. Okay, now see, this is the circuit we are using for Jones choker. This is main thyristor. It also consists of capacitor. And it consists of auxiliary thyristor, and it also consists of diode, but we can use center tap reactor. Instead of inductor, we are using center tap reactor or center tap transformer. And this is L1, this is L2. Here we are connecting some load. This is a freewheeling diode. This is auxiliary thyristor. This is Vs plus minus Vs capacitor. This chopper is called zone chopper. That means it is similar to that of voltage commutated chopper, but instead of inductor we are using center tap transformer. Center tap transformer. That means in zone chopper, it is also called zones commutation. Generally, voltage commutation is used. Voltage commutation is used. Okay. Then in zone chopper, instead of inductor, a center tap transformer is used. A center tapped transformer is used for effectively turn off of thyristor. For effectively turn off of thyristor. Okay. Then how it is effectively turn off means, we know that in voltage commutated chopper also, whatever the voltage, reverse voltage of capacitor is there, that reverse voltage of capacitor applied across the main thyristor, then main thyristor will be turn off. Then for effectively turn off of main thyristor, whatever the energy stored in the capacitor must be very high. Then only this capacitor will effectively turn off the main thyristor. But idea behind developing this zone chopper is, here whatever the energy transferred to the capacitor, if you use center tapped arrangement, the energy transferred to the capacitor from inductor to capacitor, not only due to self inductance, it is also transferred because of the mutual inductance. That means the energy transferred to the capacitor is both due to self-inductance principle and mutual inductance principle. More energy is stored by the capacitor, then that energy is sufficient for effectively turn off the main thyristor. Understood? This is the modification of voltage commutated chopper only. If you use like this, the chopper is connected like this. And this is which chopper? Voltage commutated chopper. Now I am modifying this chopper as a like this, using center tapped arrangement. Then this becomes which chopper? Zone chopper. This is the only difference. Okay. Then it is used like this. This is L1 and this is L2. Then this is which chopper? Zone chopper. That's why this is a modification of voltage commutated chopper. But here energy is transferred to the capacitor not only due to self-inductance, it is also transferred because of mutual inductance. Because of more energy stored in the capacitor, that energy is sufficient for effectively turn off of main thyristor. Okay, this about what exactly zone chopper. Okay, remaining analysis all these similar to that of voltage commutated chopper. If you want write 1 or 2 points here. Then what is the energy transferred because of the mutual inductance? The transferred energy equal to half CVC square is equal to half LI0 square. Okay, then from this, because of energy transferred from L1I square, because of energy transferred from due to mutual inductance, from this how much voltage is rises? Vc equal to I0 into square root of L1 by C. This one point to remember, this is the voltage across the capacitor. Similarly, you write what is the device turn off time? The device turn off time equal to root L1C. The device turn off time TQ equal to root L1C. The circuit turn off time TC equal to CVS by I0. Same formula you write, CVS by I0. And we define one formula here. one factor, one constant we are defining, G equal to Vc by Vs. Some constant G equal to Vc by Vs we are defining. Vc by Vs. Then what is the voltage across the capacitor is equal to G into Vs. Voltage across the capacitor equal to G into Vs. That you write. Some constant we are defining. To also write like this, what is G equal to 1 by Vs into, what is Vc? I naught into square root of L1 by C. Then G equal to I naught by Vs into square root of L1 by C. This formula you remember, this is equation 1 you remember, this is equation 2, this is equation 3, this is equation 4 and this is equation 5. And you define some resistance also. During the operation of this, we can define some resistance also. Then Rm equal to, then how we can write Vs by I naught. Now from this, what you write Vs by I naught means, you write G equal to Rm equal Vs by I naught means, we can define Vs by I naught here. Then we can define 1 by Rm into square root of L1 by C. This is some important design formulas you remember with respect to zone chopper. Okay, this is enough. In any computer exam, no questions based on this one, but you remember what exactly zone chopper. Then, what is the Morgan chopper? Listen please. But point to remember, during the conduction of this main thyristor or auxiliary thyristor, the resistance offered in this chopper is based on the design, it is very less. That's the reason why it is a more efficient chopper. It is zone chopper is efficient chopper. It is a more efficient chopper. The resistance offered is very less. Then we can write what is the Morgan chopper. In zone chopper we are using voltage commutation. In Morgan chopper we are using current commutation. Current commutation is used. Current commutation is used. In Morgan chopper we can use current commutation. But point to remember, instead of inductor we can use saturable reactor. And it consists only main thyristor. It does not consist of any auxiliary thyristor. Then what is the circuit of Morgan chopper? This is a circuit we are using for Morgan chopper. This is the main thyristor. And it consists of one capacitor. And it consists of one saturable reactor. Saturable reactor. And it also consists of one diode. And this is load. Okay. And freewheeling diode is connected here. This is main thyristor. This is capacitor. Plus minus Vs. The saturable reactor will work based on positive saturation, negative saturation. Based on these positive and negative saturations, the main thyristor will be off state. Then this chopper will. That means it consists only main thyristor. That is, it does not consist of any auxiliary thyristors. It does not consist of any auxiliary thyristor. Auxiliary thyristor. I told already what is the difference between saturable reactor and normal inductor. We know that if normal inductor means always it offers some reactance and always it opposes the current. But saturable reactor means once it is saturated, it may be positive saturation or negative saturation. Once it is saturated, the reactance offered by the saturable reactor is zero. The reactance offered by the saturable reactor is zero. Okay, that is the difference between the normal inductor and saturable reactor. This you remember as a Morgan chopper. Then it is used as a current in Morgan chopper. Which commutation we can use means current commutation is used. Okay, this point you remember. Quick. Okay, this about what exactly load commutated chopper, zone chopper, Morgan chopper. Still now in the choppers I discussed about voltage commutated chopper, current commutated chopper, load commutated chopper, zone chopper, Morgan chopper. Just I'm not discussing in detail about Morgan chopper, all this. We don't have any syllabus for commutative point of view. Just I'm giving some implementations, modifications in the chopper circuits only. Okay. Why you go for zone chopper, why you go for Morgan chopper, this I am discussing. Here we are not using any auxiliary thyristor, we are using saturated reactor. Based on positive saturation, negative saturation, then the main thyristor will be turn off. Okay, this about in detail about what exactly types of choppers based on commutation. Okay, now in the next session I will continue with another concept, that is what exactly a small concept of AC chopper, then multi-phase choppers. Multi-phase choppers important for commutative point of view. Then after that remaining two commutation methods are there, class C commutation and class E commutation. Class E commutation, that also I want to discuss. Okay, clear? Concentrate. The next session will continue.